Okay, guys, so I want to do another example. I want to do an example that has an oblique asymptote, okay? So an oblique asymptote, that is in that nice green box. That's back on page 367, okay? Or sorry, not 367, 365. And the key to that, when we know we're going to have an oblique asymptote, is when we have this situation right here, where our degree up top is actually higher, but it's only one higher than the bottom, okay? So I'm going to go through and I'm going to go through my checklist and see about graphing this. So I guess the first thing I'll do is I'll see what my vertical asymptotes are. And it looks like I have x equal to -2. Just the 0 of the bottom, that's really no big deal. So I'll go down here at -2, and I'll put that in. The equation of that is x equal to -2. No big deal. Next question I have is, do we have horizontal asymptotes? The answer is no, right? They aren't the same degree up top and down low, and the bottom isn't higher, but I do have an oblique asymptote. Okay, I do have an oblique asymptote. Now this oblique asymptote, the way we find it is we're going to actually do a synthetic division. I'm actually going to divide out x squared minus x by x plus 2. So I'm going to do this the old-fashioned way, okay? So I guess what I'll do is I'll do this right here. I'm going to do -2. I'm using my synthetic division. And then I have 1, -1, and 0. 1, -2, -3, 6, and 6. So what this answer represents here is this. This represents x minus 3 plus 6 over the divisor. Okay. So what does this mean? This is going to tell me what happens in the long run, just like the horizontal asymptotes. Now, as x goes way to the right or way to the left, let's say to the right, as x gets really big, say x is 1,000,000, what's going to happen to this term? Think about it. That would say 6 over 1,000,002. Well, that's basically going to become negligible. So in those steps, when they talk about oblique asymptotes in the beginning of the section, when they say ignore the remainder, that's why. But in the long run, it's going to approach 1,000,000 minus 3. Okay? Or, well, whatever the value is minus 3. So whatever our x is minus 3, that's what we're approaching as we go really far to the right or really far to the left. So I'm actually going to put that in. And I know what that looks like. X minus 3 is linear. I know it intersects here and goes like this. So this is an oblique asymptote. And the equation of it, the oblique asymptote, is y equals x minus 3. So know how to find that equation, okay? Just forget about your remainder. Now, just like the horizontal asymptotes, it is possible to cross these, and we'll see how we can check that, okay? So let's see. We did our oblique asymptote. That's fine. Now, I want to find any y-intercepts. So I guess step 3, y-intercept. I know for that, I just do f of 0. And in our case, it's going to be, looks like it's going to be 0 times -1 over 0 plus 2, which is just 0. I plugged it in to right here. So I know that this thing is going to go through the point 0, 0. Okay, that's fine. So we're going through right here at 0, 0. I guess I can give that point. Okay. And the next thing I want to do is I want to look at any x-intercepts. So let's go up here, step 4, x-intercepts. We know we can just set the top equal to 0. So x times x minus 1 is equal to 0. Well, two cases, x equals 0 or x equals 1. I actually have one of these already with the 0, 0 down here, but I also have the point 1, 0 apparently. So that's going to be right here. Okay, so that's the point 1, 0. So I got my x-intercepts and my y-intercept. That's great. Now, I want to see if we ever cross this oblique asymptote. And if it does, where that occurs. So just like we did with our horizontal asymptote. So I'm going to do the same thing. Remember how we would take our function and we would set it equal to the horizontal asymptote? Well, now I'm going to set it equal to the oblique asymptote and see if I get anything that makes sense. Okay, so I have x squared minus x over x plus 2 equal to x minus 3. I guess what would make sense is to get the x plus 2 out of the denominator. So I can multiply both sides by x plus 2. So I get x minus 3, x plus 2, x squared minus x equals x squared plus 2x minus 3x. That's going to be minus x minus 6. If I try to get the x squareds on the same side, that's not going to work because they'll cancel. Same thing with the x's. If I add x to both sides, at this point, I'm going to end up with 0 is equal to negative 6. Since I ended up with nonsense, I see that, okay, well, looks like it's not going to cross. Okay? So I'm right here and I'm asking myself, well, what's happening? Well, if it can't cross, and I know that it'll get close to the horizontal asymptotes as time goes on, I know that this has to be shaped in this sort of a manner. Probably makes sense for me to do this in black here. And it dips down, but it has to come up and hit this. And as time goes on, it's just going to get closer and closer to y equals x minus 3. I know it's not going to cross because I would have picked that up here. Okay. If you're unsure, you can always test a point here or there, right? Okay. And the question is, okay, here, is this going to come out here or is it going to come out way down here? Well, this is an odd multiplicity, right? The linear corresponding linear factor. So I expect this thing to pop out down here. Let's just check just in case. So see how x is negative 3 here. Let's see if it's way down here. So let's try, I guess this is step 6, f of negative 3. If we try f of negative 3, what is the function value? Okay, well, that's going to be negative 3 times negative 3 minus 1, which is negative 4, over negative 3 plus 2, which is negative 1. 3 negatives, that's negative 12. So that tells me at negative 3, the function value is negative 12, which is way down here. So that helps me feel confident of that. So I can even put that point if I want, negative 3, negative 12. And I'm going to approach that vertical asymptote. And the only other place to go over here is to get infinitely close to my oblique asymptote, but never cross, right? So that's an oblique asymptote example for you guys.